Hello students, welcome to the next lecture on the sequence and series. Today we will discuss about ratio test. Myself Dr. Garg, working in the School of Mathematics, Thapar Institute. You can simply follow my YouTube channel Dr. Harish Garg, where you can find the various videos on the sequence and series as well as real analysis. So let's start with this video. What we have discussed in our previous lecture, we have discussed all those testing of all those convergence testing related to the infinite series. Now in this lecture we will discuss about this ratio test and explain with the help of 10 to 12 examples. What is the Cauchy ratio test is? If you have the positive infinite series, what is the meaning of the positive infinite series? That means an is always be the positive for all n. Then it's said to be the positive infinite series, such that if you take the ratio an plus 1 upon an is L, and if L is less than 1, then we can say convergent. If L is greater than 1, we can say as a divergent. But if L is equal to 1, then we can say the test failed. The proof is very simple. What is given to you, since the limit is L, so by the definition of the limit, we can say right here. We can open this limit, which is written like this manner. Now, since n is my greater than or equal to m, so I can take n is my m, I can substitute here, we will get this equation. I can take m plus 1, we will get here, and so on up to the n minus 1. Now if you multiply all these terms, so what will happen if you multiply them? So am plus 1 will be cancelled out, am plus 2 will be cancelled out, an plus 1 will be cancelled out, and you will get this expression. Now there are the two cases, whether L is less than 1 or greater than 1. So when L is less than 1, so then you can find epsilon, which is positive number, such that L plus epsilon is less than 1. You always find the value of this. Now L plus epsilon is related to this. So can you find the value of an from here? You can multiply them. You will get this as the expression. From here you can say I can multiply them. I can take m portion separate, n portion separate, and then take this summation on both sides. So this is a constant number with respect to the n, and you can see this is a geometric series. This is a geometric series with the ratio r, which is nothing but less than 1. So therefore by using the geometric series test, this series is convergent. Hence this series is convergent, so therefore an is also convergent. On the other hand, when you take L is greater than 1, what will happen? You can choose epsilon, which is positive, such that L minus epsilon should be greater than 1. So we can write here. So L minus epsilon is this one. You can find the value of the an from this and take this summation on the both side. Again, this is a GP series, but the ratio is greater than 1, so which is the divergent series. So by the comparison test, this is also divergent series. So remember, we have discussed in the last lecture, we have discussed these root tests are there, and in this lecture we have discussed about the ratio test. So how do you know that which test is applicable to solve the convergence of the series? Whenever any of the series which involve the factorial terms like of this, then we always prefer to use the ratio test. However, any of the term which is raised to power of the n, like of this, then we are using the root test. Anyhow, we can also solve these two problems with the help of ratio test, that we will see in this lecture as well. So let's discuss about 10 to 12 examples so that you can able to understand more clearly. So first of all, you can see this is the power of n, so you can apply the root test as well. So with the same problem we have discussed in our last lecture. So right now we are trying to solve this problem with the help of ratio test. So this is given to you an. Our target is to find this ratio and check whether it's a less than 1 or greater than 1. So what is the an plus 1? So you can see an plus 1 is nothing n plus 2 raised to power 10 divided by 10 raised to power n plus 2. Now take the ratio, we will get here. So what is the limit of this? So we can take the pair. We can take the pair of this n plus 2 over n plus 1, and I can take the pair of this n plus 1 minus n minus of 2. So what will happen? You will get this answer. Now you can take as n approaches infinity, 1 by 10 is outside. I can divide and divide it both sides by n, which is goes to the 0. This is 0, that's here. Clearly says that this limit is by less than 1. So by ratio test is a convergent. Now again in the second example, you can see this is the factorial. So you have to apply this ratio test. So what is the an plus 1? You can clearly say that this is my 2n minus 1. If you substitute as n is my n plus 1, it will be as a 2n plus 1. Now clearly says that it will be cancelled out. 4n it will be cancelled out. 2n it will be cancelled out. N plus 1 factorial I can open it as here. So this is 1 by 8 is outside. I can open it. You will get as 2 by 8, 1 by 4, which is less than 1. Again the series is convergent. Again there is a factorial are there, so you have to apply the ratio test. So how you can solve that? You can see what is the an plus 1. So I can write this is my n plus 1 raised to power n plus 1. This is my an, and this is n factorial divided by here. I can take the pairs. Now you can see 1, this will be cancelled out. I can take this as n common, which can be written like here. So which is the 1 by e, which is less than 1, is a convergent series. Here you can also apply the root test, because it's a raised to power n. That I already discussed the same question in my previous lecture. You may watch them. Otherwise in this lecture we will try to solve with the help of ratio test. So what is the limit of this? You can take the pair of this, so it will be cancelled out. So it will be 3. From here it will be 2. I can take this as a cube common. So what will happen? What is the limit of this? Is the limit is my 1 as n approaches infinity. So you will get as a 3 by 2, which is greater than 1. Hence the series is divergent by using ratio test. Look about this one. Now in this case, x, what is the nature of the x? Is x is positive number? Is x is less than 0? Is x is 0, or what is the nature? It is unknown to you. But clearly says that x must be a positive number, because if x is negative number, then it is a negative series. But the ratio test is applicable only for the positive infinite series. So we can put the condition as here. Now this is my an. Now we can find this ratio. So what is the limit of this? We can take the pair n plus 1, and n I can take this pair. I can take this root of this. This is n plus 1 square plus 1, and this x and x will be cancelled. It is my x. Now what is that? I can take, what is that? This is nothing, 1 upon here. I can divide it numerator and denominator by n square. So it is 1 plus 1 by n whole square plus 1 by n square of x. Now you can take the limit as n approaches infinity. This part will be 0. This is 0. This is 0. So it's a 1. It's a 1 plus 0. That's a 1. It's a 1 plus 0. This is 1 upon 1 plus 0 of x. Answer is x. But what is the value of the x? So that's depending upon the ratio test. When x is less than 1, it's a convergent, otherwise divergent. But what will happen if x is equal to 1? Then the ratio test fail. So what will happen if it fail? So we have to check the nature at x is equal to 1. We can substitute x is equal to 1 here. What is the an? An is my this one. Now you have to check either by our previous method, by we can use by either the nth term test, we can use the either as a p test, we can use as the partial sum sequence test, we can use as the geometric series test, or you can use as a root test as per your choice. So you can easily see that if I take the limit, firstly we can try for the nth term test. What is the limit of this? So clearly says that if I divide it both sides by n, it will be my of this. So what is the limit of this? It is my 1, which is non-zero. So once it is a non-zero, what is the meaning of that? So by the nth term test, it is a non-zero. So by the nth term test, it is a divergent series. So therefore at x is equal to 1, it is also the divergent. So we can put as the equality here. This is the answer of this problem. Look at another one. Again, this is unknown x, so we have to put the conditions on the x. So let's start with this an plus 1 upon an. So what is the limit of this? So clearly says that this and this will be cancelled out. It will be x. So I can write like here. What is that? As n approaches infinity, so 1 by 5n will goes to the 1 over infinity, that is a 0. So this part is 0, this is 0, this is 0, this is 0. So 5 is cancelled, that is a x is my answer. Depending upon the nature of the x, if it is less than 1, greater than 1 or equal to 1, it's a 0. What is will happen if x is equal to 1? So we can find the value of an. I can substitute x is 1, that's here. We can write this. Again, we can apply either of the test, either the nth term test, partial sum sequence test, limit comparison test. We can apply the p test. We can check about the geometric series, or we can check about the root test as per your applicability. So firstly, we can check about the nth term test. We can find the limit. Again, we will get the non-zero. So that means this the nth term test is a divergent. If it is goes to the 0, then we have to apply for the another test. So once equality is a divergent, we can write it as equality here. Look about the another two. Again, this is a factorial, and this is a factorial. We again apply for the this one. That is a ratio test. So what is that? If you find the limit of this, what is the limit of this? So we can take 3n and 3n plus 1, that is my 3, xn plus 1 and xn, that is divided by x. I can take the factorial as n plus 1. So what is the limit as n approaches infinity? That is infinity, which is greater than 1. So once it's a greater than 1, it means it is a divergent series. Look about this one. So we can find this series. What is the limit of this? So 2n, I can open this one, 2n plus 2, 2n plus 1, and after that 2n, it will be cancelled out. N plus 1 factorial and 1, I can open this n plus 1, 1 n plus 1 factorial, and n will be here. Now clearly say that if we take the 2 common, it will be cancelled out, it will be 2. So the limit is my here. Now you can divide it both sides by n, you will get the limit as 4, which is greater than 1. Hence again it's a divergent series. Look about this one. That's again there is an unknown number of the a. So again we will impose the conditions on the a. What is the an plus 1? So you can say this is a 2n, this is my n plus 2, and this is my n plus 1 divided by an. So there is a n plus 1 of root n. We can take the pair of this. We can take the pair of n plus 1, n plus 2, root n and root of this, and 2 of this we will get here. We can divide it this numerator and denominator by n. We can divide this numerator and denominator by n, and is the answer of this a square. So depending on the nature of the a square, because a square is always a positive number, so the lower limit is my 0. So what will happen if a square is 1? So it means either a is my plus 1 or a is my minus 1. So if you take a is plus 1 first case, second is a is minus 1. If you take a is plus 1 here, what will happen is an is 1 raised to power of this, and if you take an, it is minus 1 raised to power of this divided by n plus 1 root n divided by n plus 1. So what is that? This is always with a plus 1 over this part. This is also the plus 1. So it may both the results have the same. So we can substitute a square directly at here. I can write this number as of this. So I can substitute a square directly at here because these have the same result. So I can substitute here. Now if you take the nth term test, what is the limit of this? It will goes to the 0. So it means nth term test of the divergence is not applicable. So we can apply the limit comparison test. We can take the limit bn. How you can take? What is the maximum value of the n here is n, and this is root n. Take the ratio of the an and bn, which is a non-zero finite, but what is the series of bn? I can write this as a 3 by 2. What is that? 3 by 2 is my convergent by using p test. What is the p test is? Here p is my 3 by 2, which is greater than 1. So therefore by comparison test, this is a convergent series at a square is 1. So now we can write here as equality of this case because of convergent. Look at the another example. So what is the nth term is? This is my nth term of the series. I can write here. We can take the ratio, we can divide them, and we will get the result as x square depending on the nature of this and here. Again we will see x is either plus 1 or minus 1. When x is plus 1, Again, now you can see you can't write this in terms of x square of power. You can't write that, but we in the previous example we did that. So in this case we will write the two different result. When x is 1, we can substitute x is 1, it means this value is my plus 1 here. So what is that? If you take nth term test, what is the limit of this? It goes to the 1, which is non-zero. So it means it is a divergent by using nth term test. When x is minus 1, so what is that? This number is my minus 1 raised to power 2n minus 1. But you can see 2n minus 1 is my odd number. So once is an odd number, so this number is my minus 1. So I can write here. Again, you can apply the limit test, which is again the divergent. So by the nth term test, at x is equal to 1, at x is minus 1, both are my divergent. So we can write equality at here. Now in this case, you have to write the a and term. So clearly says that this is x square. So I can write this as xn. So but this 1 is extra term, so we can omit that. Now this is 3, this is 6, this is 9. So the numerator is my multiple of the 3. So I can write as a 3n. What is the denominator? You can see it's a 7, then 10, then 13, and so on. So you have to see what is that. This is my plus 3, this is plus 3. You know what is the series? It's a AP series. What is the nth term of the AP series? That is a plus n minus 1 common difference. First term is 7, common difference is my 3. So it is my 3n plus 4. So I can write this number as of 7, 10, 10 and 3n plus 4 by omitting the first term, because you can't correlate the first term with any of the series. Now you have to make the an. You can find the an plus 1 upon an as this one. Clearly says that you can cancel out these terms, divided both sides by n. What is the limit of this? You will get the answer as x. Depending upon the nature of the x, you can say the series is convergent and divergent. Again, when x is equal to 1, the test fail. You can substitute here and check what is the nature of this an. Okay, look about the another examples. So again, this is my an is given to you. You can find this limit. We can take the pair of n plus 1 over n whole square, and for this part it will be 1 over e. What is the limit of this? It is a 1. Answer is 1 over e, which is clearly is a less than 1, because e is my 1.278, which is less than of the 1. So once it's a less than 1, so it's a convergent. Again, for here you can find the ratio. This we can take the pair 4n plus 1, 4n, it give you 4. N plus 1 factorial or n factorials, it give you 1 n plus 1. Similarly for here, for the denominator you can open this, then 2n plus 1, and then 2n will be cancelled out. So this is the limit. You can divide it, numerator and denominator, by n, or you can take as a 2 common, it will be cancelled out, and it is my 2 here, divided both sides by here. Clearly says that once it's a 1, it's a test fail. But how you can check the nature of this? So that's a very simple. It means you have to apply some another test. You may apply, say, a Rabi's test. You can apply the logarithm test. You can apply the Gauss test. But that we are not discussed here. But another way is, look about the an. What is the a1? You can see that a1 is my 2, which is the positive number. Look about this an plus 1 over an. You have to find them, which is nothing but my here, and that is always be greater than 1. So what is the meaning of that? It means an plus 1 is greater than an. That is, sequence an is my increasing sequence. So once it's an increasing sequence, the first term is start from the 2. That means if I say this is my 2, the first term is start from here and it's increasing. So it means, can this limit be a 0? No. So it means the limit can never be 0. So once it's a never 0, it means by the nth term test, the series is divergent. So this series is my divergent by using this concept. Now these are the exercise for you. You can see these are the 5 questions are you. These are the answers. They are the another 5 questions which are given to you as a practice purpose. Let me know in the comment box whether these answers you are able to get the right answers for these 10 problems. Till then, we will see the next lecture on the Leibniz test for the alternating series. You can keep like, share and comment these videos with your friends. Best of luck students. Happy learning.